Hey guys, Mrs. O'Donnell here. Today we are continuing with completing the square, but we're going to look more at how to use completing the square to solve quadratic functions. Again, make sure you are checking out the agenda. I will post the video link in the agenda as well. I just obviously am making the video right now. Hopefully you did fine with Monday's assignment. Checked out that GeoGebra applet a little bit, and then tomorrow we have a game. So hop on, you could play with that a little bit now even. It's just some general completing the square practice. All right, so let's take a look here. So first of all, I want you to, what you see here is we see some algebra tiles, right? So if we write out the equation that's modeled by the algebra tiles, then solve it. So what I see here is an x squared, 1, 2, 3, 4 x's. So I have x squared, let's see here, maybe I can even color code it a little bit, plus 4x equals -2. That's what that equation looks like. Okay, so I've got x squared plus 4x equals -2. Well, if I start doing this by completing the square, I know x times x makes x squared, and then I've got 2 and 2, but what that does is it adds on 1, 2, 3, 4 singles, right? And anything I do to one side of my equal sign, I have to also do to the other, right? So I'd have to add on 1, 2, 3, 4. Okay, so now I've added 4 to both sides of my equal sign, right? So I've added 4 here and here. And if I work that out, I have x squared, let's see here, plus 4x plus 4, right? Nothing combines there, equals, and then my -2 and my 4, those can combine, right? -2 plus 4 leaves me with just a +2. All right, and if we check out our, our algebra tiles here, that makes sense. And we see, hopefully at this point you already see, there's another way that we could write out this x squared plus 4x plus 4 because it is a perfect square trinomial. We could write it as x plus 2 quantity squared, and that's equal to 2. Okay, so far we haven't really done anything new. We're kind of looking at it using the algebra tiles, but we really just completed the square for that original problem, right? We added that magic number to both sides of our equal sign, simplified. I'm a little worried that that 2 looks kind of like a 1. This is a 2. Okay, so, but my goal is not just to complete the square, but my goal is to solve the equation. I want to know what x equals. Well, remember what we learned last week. When you have quantity squared like this, you can use SADMAP, right, for solving, okay? And when we're using SADMAP, or inverse order of operations, we are doing the opposite, right? So the inverse operation to that square is going to be the square root. And if I do it to one side of my equal sign, I have to make sure I do it to both sides of my equal sign. The square root of my square leave me with x plus 2, and then the square root of my 2, unfortunately, that doesn't work out nicely, so I would just have plus or minus the square root of 2. That's an irrational number. Okay, and let's see here. I'm not quite to my final answer yet. I still have this plus 2 attached to my x, so I have to get rid of that by doing the opposite. The opposite of plus 2 is -2. If I do it to one side of my equal sign, I have to also do it to the other. Now, this is where it might look a little tricky. I personally, right, plus 2 minus 2 makes 0, so I'm left with just my x. I like to take this -2 and write it out in front. So I have -2 plus or minus the square root of 2. And this is where you probably are going to grab your calculator and maybe just do some rounding. Sometimes you want to leave the answer exact, so you're very precise, but sometimes you just want to round it, right? So our square root of 2, that's about 1.4, right? So negative 2 plus the square root of 2 is going to give us negative 0.6, and negative 2 minus the square root of 2, or minus that 1.4, is going to give us negative 3.4, rounded to the 10th place. Okay, so our two answers here would be negative 0.6 and negative 3.4. And it's always a good idea to go back to that original problem and plug back in to make sure that your both answers work. All right, let's check out another problem here. So again, let's see here. It says solve by completing the square, right? Write the equation modeled by the algebra tiles and then solve. So it looks like the equation that we have here, we have x squared plus 1, 2, 3, 4, 5, 6 x's, right? And that is equal to 1, 2, 3, 4, 5, but it looks like that's a negative 5 singles. All right, and if I'm completing the square, I'm adding in, right, all the singles that would make this, that would finish off this area model, that would make this a perfect square, right? So I'd end up with x plus 3 and x plus 3, which gives me 9 that I'm adding on. But just like every other problem we've ever done, if you add something to one side of your equal sign, you have to add the exact same thing to the other side of your equal sign. Let's see here. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so it looks like if I did that, I would have x squared plus 6x, let's see here, plus 9 is equal to negative 5. I add to one side, I add to both sides of my equal sign so we can sort of see the algebra tiles, but we can also see the actual algebra happening here. So x squared plus 6x plus 9, that's my perfect square trinomial that factors down to x plus 3 squared. And negative 5 plus 9, well, that leaves me with just 4. And we see that right here. We have 1, 2, 3, 4. All right, and then now at this point, remember our goal is to solve to find what x equals by completing the square. So this is where I'm going to grab onto my inverse operations and start undoing or getting things unattached from that x. So the first thing that I can undo is that exponent. The inverse operation to the square is my square root. If I do it to one side of my equal sign, I can do it to both, right? So the square root and the square undo each other and leave me with x plus 3. And then the square root of 4 is plus or minus 2. All right, and then I want to get rid of that plus 3 by doing the opposite, which is minus 3. If I do it to one side of my equal sign, I do it to both. So I end up with x plus 0, which is just x, and then negative 3 plus or minus 2. So I'm going to actually do that. I'm going to do x equals negative 3 plus 2, and I'm going to do x equals negative 3 minus 2, right? I'm going to split that into two problems. So negative 3 plus 2, that gives me negative 1. And negative 3 minus 2, that gives me negative 5. I want to make sure at the very end, when I think I found my answers, that I check my work by going back to that original problem, right? So the original problem is x squared plus 6x equals negative 5. So I'm going to test it out. If I plug negative 1 in everywhere I see an x, am I going to get back a negative 5? So let's see here. Negative 1 squared is 1. 6 times negative 1 is negative 6. and 1 plus negative 6, that's negative 5. Negative 5 is equal to negative 5. So far, so good. Let's try it for negative 5. X squared plus 6x equals negative 5. I'm going to plug a negative 5 in everywhere I see an x. Negative 5 squared is positive 25. 6 times negative 5 is negative 30. And 25 plus negative 30, that's negative 5. Is negative 5 equal to negative 5? Yep. So my check worked out and both answers work. Every once in a while, you'll have a situation where an answer doesn't work. You'll get into that more in Algebra 2. But you definitely need to make sure you go back and check to make sure that both answers work. All right, so let's take a look at what this process looks like if we're just doing the algebra, right? So I've got x squared minus 2x equals 1. I want to solve it by completing the square. So one strategy that may help is remembering you have to make a perfect square trinomial, right? So in order to make that perfect square trinomial, you have to add a number. And anything you do to one side of your equal sign, you have to do the exact same thing to the opposite side of your equal sign. Okay, so my perfect square trinomial here, right, we have to figure out what is that magic number that complete the square number. Okay, and if it helps you, you can come off to the side. You can make your box, right? We know we've got x squared, x and x. Okay, and that might show you all 1, or maybe you remember what I said that formula was for that magic number, b divided by 2 squared, right? So negative 2 divided by 2, which would be negative 1, squared is positive 1. So in this case, we're going to add 1 to both sides of our equal sign. All right. So I know that x squared minus 2x plus 1 makes that perfect square trinomial x plus 1 squared, and 1 plus 1 is 2. Okay, so now I've got it into this format with factored form that's going to allow me to solve it, right? The opposite of a square is a square root. If I do it to one side of my equal sign, I can do it to both. So I've got x plus 1 equals plus or minus the square root of 2, right? Subtract 1 from both sides of my equal sign. So I've got x equals negative 1 plus or minus the square root of 2. You could also just break that down. X equals negative 1 plus the square root of 2, and x equals negative 1 minus the square root of 2, right? That plus or minus means that you're actually doing two separate problems there, okay? At this point, you could grab your calculator, actually do the math to figure out negative 1 plus the square root of 2 gives you 0.4 rounded, and negative 1 minus the square root of 2 gives you negative 2.4 rounded. Problem in here before the end of our session. So we've got x squared minus 4x equals negative 1. Remember, the first thing we have to do is create that perfect square trinomial. Any number we add to one side of our equal sign, we have to add to both sides of our equal sign. I'm going to grab my b divided by 2 squared. So let's see here, negative 4 divided by 2 squared, that makes negative 2 squared, which is 4. So my magic number here is going to be 4. Okay, so I've got x minus 2 squared equals 3, right? Square root both sides. X minus 2 equals plus or minus the square root of 3. Add 2 to both sides of my equal sign. X equals 2 plus or minus the square root of 3. Grab your calculator, calculate it out. 2 plus the square root of 3 is 3.7 rounded, and 2 minus the square root of 3 is 0.3 rounded. And that's about all I've got for you today. Thanks so much. See you in office hours.